Thanks for tuning in. So, as you know, this channel is based on creating content that is original. So, I'm spending a tons of efforts on doing my own material and not just copycat something somewhere. I work a lot on the overall security architecture, and in terms of AI security architecture, you find a lot of material that is really focusing on something. After OpenCloud, for example, there was a lot of architecture conversation, but so specific into the agentic space that it was completely missing the big picture. In some of the material that you find around, you have also specific attack surface, specific zoom in, but what I notice is that there is no real AI threat model in the meaning that I do give to that word. So a real picture of the overall zoom out of the overall design. So let's try to do and build it together. So now we are going to see what is the actual picture. We have an ML system and we have an AI system at the end. One is into the other one because you do have a system prompt space. You have going to have a user prompt, user input space, and you have an external data or data retrieval space. Let's call it data retrieval space. Now, let's say that this one is the backend system, and as any of its design, it does have a front end like that. Okay. On live, so you need to be a bit patient. So this one is the front end. The retrieval space can be done of something like a rag, a graph, something that is borderline kind is Iceberg Apache alike. Now, all these components are part of a data retrieval, and obviously whatever is connected to that can actually have an impact in our threat model. Okay, so this one is the picture. Let's put the client and the user facing the front end. Or we can have a system that is connecting to that. In that case, user system. So this side is anyway the client one, and the user system is going for sure through a CDN. that will be part of this front end. Okay. Into that we will have also the API, external interface like an MCP as well, but at the end is an API for these systems. And we can claim that we have an overall kind of picture. Now, if you are looking into this space, the data retrieval layer could be actually not externally hosted. So we need to consider also the interaction with the infrastructure, external infrastructure, let's call it, that is hosting all these data retrieval space. So we consider this one as the potential external cloud infra. There, obviously, you're going to have some overlap of API, some overlap of MCP. You do have also another layer that can be an ETL. Pipeline. You have a CI/CD pipeline. Let's put it here. Nine. So the ETL pipeline is actually really close to all this data, because if you think it's part of embedding the vector database and all other stuff. So let's put it here. And this one as well. So now client connect to CDN. There is the deployed front end. This one is the main AI system backend that is divided by system prompt and user input. Now, system prompt is where it's happening an indirect prompt injection. For example, retrieve an email, take a command that is within the mail and perform an action. That a type of attack is actually happening in the system prompt. If you have a direct prompt injection is happening at user input. Can be about the encoding, the tokenization of the raw input. Okay. This one is the overall picture of all how is connected all this stuff. Now, this one is also a SaaS service, so it does have a component of memory that is something that we need to put on top here because it is also shared across the system. Let's put it like that, shared memory. Now, in this pipeline, we should also add what we connect to the AI itself, but I will put it inside here so we can have S3 buckets, GitHub, supply chain kind. Obviously, it's integrated in the system. It can be integrated in the ETL. It can be integrated wherever. This model, you don't see it all in one shot. Most of the time when you see all this conversation about AI, it's not about the big picture. Now, an attacker can work on the system, but it can work also on the ETL pipeline. It can have access and exploiting the API of MCP. It can have a token problem where some token get exfiltrated through the CI/CD pipeline. You can have CDN cache poisoning. You can have a front-end compromise that is connecting, or you have a third server, but let's put it here in the external infra cloud stack, and we put also the CI/CD into that because it's anyway compare. So if you look, we have all these interfaces that I would call it more like interfaces because it doesn't matter. At the end, MCP is a sort of API in any case where you are having all connected. Now, when you are going to do an analysis, understand what is north and south, what is east-west is extremely complicated because all these services are scaling across and are probably having the CDN in somehow between as well. So now you need to think that each design is different, but these systems are anyway having a shared memory. If one node goes down, it's not that it's restarting the conversation from scratch. There is some sort of sharing. So access to the memory, access to the identity, all these considerations need to be seen, but the model of a threat model should be complete like that. You should see, for example, if there is a reinforcement learning and what it can be used to change the LLM itself. So this one is a quick walkthrough to show you how much of each conversation that you are having about risk, attacks, is just one piece. You need to connect the dots. That is why my mantra is always connect the dots. Try to see the big picture. In the system prompt, you have all these system that can retrieve information from buckets, from system. Think about Copilot, for example, or whatever. So you need to see also the connectivity, how is performed, the rotation of a token, if there is some, the identity layer. So you need to have on top also all these layers together to see the big picture. So how it's happening, the authentication across all these layers. I hope you find this snapshot useful, at least to connect a bit the dots. If you take an example of a classical GCP into Vertex, for example, you can have some mixed component. For example, you can have a BigQuery where you collect all this data, and later you could have an Apache Iceberg, or having an external component that does the embedding of all this RAG. If you place the agent, because the agent are the big conversation, you have a chain of minion that are actually really critical because they are going to be a full mesh. So when you are going to look at, you are actually creating a sort of pipeline across agentic, but you need to pay attention that all these agentic can have a layer that is like this one with memory too, because the memory is now something that in agentic is going really something important for the agent to not restart from scratch at time, but he will have also RAG not seen now yet all portion of graph on that more RAG. So all these, it will be also the pipeline that you create into the agentic, and you'll need to consider as well. Now this agentic obviously is using connectivity, is using MCP, so there are internal connection. But this one should be the overall threat model and how you map. One of the gaps that you are having when you are talking about threat model, if you go through a Stride, for example, was really designed for application. That's the reason why it is almost 10 years that I advocate, and you'll check my resources, you'll find also way how I explain how to do a threat model of an infrastructure. Now you can have a Zoom for each and have an application threat model within that, but you need also to correlate the infrastructure that is guesting and how each component is talking to each other. Don't forget that, because you need to have an overall picture of, for example, you deploy some container, the microsegmentation across the pods of that container are still part of this analysis. So this one is an high level, but later you zoom into the application, into the east-west of each. You are trying to see each component. If this one is in a way within an infrastructure on-prem or is about a SaaS, doesn't change. What is changing is obviously the exposure of that services. And if you have an AWS Bedrock or something, you are trying to keep it within your subscription. So it's really important that you design the square of each boundaries and you see where is crossing the boundaries and where you have the DLP, for example, around it. Think about all these data that get ingested by the ETL pipeline and how we get embedded later into a vector database. Where is the vector database? How get connected to the vector database? So please leave me a feedback about this video. I'm really interested to know if there is something that you want me to zoom in, and I hope you like it. And I will try to keep this format because I want to create content that is original. So like and subscribe. Okay? Thanks a lot for your time. Cheers. Bye bye.